Hey folks, welcome. We're getting started a few minutes early just to give everyone some time to trickle in here. Um, we have 18 people online right now, and that number is probably going to tick up quite a bit. We have 100 people registered for this, so we're excited to have you all here. If you want to just say, hey, let us know where you're from, throw it into the chat. We've had folks from all over the world in past BIM forum presentations, and really interesting to see where BIM has taken us. So I'm John Tachi. I am PCL's Manager of Innovation and Technology and also the co-founder of the BIM Forum, which in just about 2 months is coming up on its 20th birthday. So one more year and it will be old enough to drink, I guess. And with me is John Russo. John, why don't you just, I know we've got a formal presentation, but we'll just get started with a little chat. So maybe you can introduce yourself to folks on the phone.
First of all, congrats. That's a cause for celebration, certainly. Yep. And John Russo, I've got an intro slide, so I'll just talk about it now. I'm a licensed architect in Southern California. We specialize in reality capture, and also kind of like John, founded the USIBD, U.S. Institute of Building Documentation. So kind of the founders forum here, I guess.
Yep. So we got Naveen from India, Aina from Fort Collins. Is that CSU? Is that Colorado State University? I'm guessing it's not California State University, but everyone's got a CSU if the state starts with an S or C, I guess. Yeah, hooked on phonics. And Radu is one of our members of the BIM Forum Working Group Advisory. So great to have you in the audience as well. Is it Randy, or maybe you can give me some phonetic help? Thank you, Ina. Yes, Colorado State. But Randy said that BIM drives a lot of people to drink. And at one BIM forum, we actually had a BIM meeting, but it was beer and meeting. And I don't know if we got a lot done, but we certainly shared a lot of challenges with each other, open and honestly. So it was great. That being said, John, why don't I let you launch into the formal presentation here?
Yeah, no, thanks, John, or John Jr., I think everyone calls you. So today we're talking about reality capture and the state of the industry. Before we get started, any of those out there that are looking for AIA credits, go ahead and drop your member number in the chat, and then those will get picked up, and you get one learning unit for this presentation. So with that, we got our agenda today. Basically, this introduction, we're going to talk a little bit about Reality Capture 101, just some basics. We'll go over some of the core technologies that we're currently using in Reality Capture. A little bit on the kind of the scan-to-BIM, Reality Capture to BIM workflows, and then wrap it up with a little bit on the what's out in front of us, the future, AI, automation, digital twins. We're hearing a lot about these days, and some Q&A at the end. Again, John Russo, Architectural Resource Consultants is my company. Been in business since 1997. Been in the industry a long time now. 1982 started in working for a design architect. Did that for about 13 years. Started my firm ARC, and then been doing this, specializing in reality capture for 28 years now. So it's crazy. Time flies. Also founded the USIBD, U.S. Institute of Building Documentation, back in 2012, along with a number of other leading reality capture folks, and then I've authored some publications, spoken at many conferences. So let's look at, why does reality capture matter? There's a a growing need for this, obviously, in the industry, the AEC industry. Probably really started becoming more important as the shift from 2D to 3D started happening, probably back around 2008 or so. The industry started shifting over to BIM. I think a lot of that was, during the financial crisis and the meltdown, and people were becoming unemployed. And it's like, hey, I'm going to pick up a new skill and learn this BIM thing. So we saw a lot of that. At the same time, laser scanning was starting to come onto the scene more. So these 3D worlds started taking off. It also matters because of, where things are going with digital twins. We'll talk about that. There's regulations, industry standards that always follow new markets. It takes a while for that stuff to catch up to all the innovation going on. And then ultimately just kind of bridging the gap between construction and handing over the keys to the owner, and then using this data for managing the buildings during the life cycle.
Yeah. I mean, John, just to chime in why it matters selfishly from a GC's perspective, we have so many tight tolerances, and we buy a lot of precision work from our subcontractors. So knowing that we're getting what we pay for is critical, because many times our documents don't give us a lot of grace. ADA, you gotta meet that ramping elevation, and if you don't, you're in deep sneakers. So we're living in a day and age where those tolerances absolutely matter.
Right. Well, it's design intent, and then it's up to you guys to implement, right? So it's and that's not always easy. Today, kind of, again, 4 kind of major segments: reality capture 101, core technologies, understanding the workflow, and future trends. So if anyone ever comes across reality capture, existing conditions, most stuff you encounter, not always, but a lot of times it's not square, plumb, or level. And bonus points to anyone who knows what building that is. So reality capture, basically, what is reality capture? Reality capture is digitally documenting the built environment, really, for the AEC world at least. And why is it critical? We talked a little bit about that, but ultimately it comes down to making sure you know how accurate things really are. It helps with your efficiency, risk reduction, and cost savings. It's a lot like an insurance policy. Common applications, these are kind of the big things that we use it for: design, construction, facility management, a lot in historic preservation as well. Let's look at some of the core technologies and workflows. We'll start out with laser scanning, probably the most common thing we talk about and think about with reality capture. We'll start with terrestrial laser scanners. So these are basically tripod-based scanners. You pick it up, set it down, take a scan, move it, take another scan, take another scan. These are really high accuracy instruments, great for interiors and exterior documentation. We're also seeing a lot now with mobile scanning. And these are a lot of them based on SLAM. You'll hear the word SLAM. Technology stands for simultaneous location and mapping. So as you're moving through the space, the laser's tracking your location, and at the same time it's capturing measurements. So it's a little different than the terrestrial, but it's super fast, maybe 5 times as fast as a terrestrial workflow. It can vary, but some of the trade-offs, not as accurate. It's accuracy is less. The data quality isn't as good as a terrestrial laser scanner. So it's just another tool in the toolbox. So certain strengths and weaknesses to both types of tech. We also have kind of more on the, when I say structured light scanners or articulating arms. These things are at least the three on the left side of the screen, more on the metrology end of the scale, scanning objects, small things, high precision on some of these, sub-millimeter. Not as common in building applications. Maybe if you're scanning and documenting a gargoyle on a building for a historic preservation project or something, you might use something like this. But then on the right side of the screen, we got two black units here. Those are the Matterport Pro 2 and Pro 3 camera. The Pro 2, that is that's a structured light sensor. So it's got some limitations. Works really good interiors. Great for virtual tours. Super high quality imagery. Measurements are not great. Measurements are really not great. They introduced their Pro 3 version, which introduced a LiDAR unit in it. So it's not just structured light. So that enables you to now scan in bright sunlight and not have the same problems you had with the Pro 2. But this is like a, maybe an $8,000 camera versus an $85,000 terrestrial laser scanner. There's going to be accuracy differences. So just be aware of that when people are talking about trusting measurements out of a Matterport.
All right. We got an answer from Jan and Jim Bedrick on that picture with, I think it was a Faro X330 in it.
Yes. Yep.
So, was it Watergate? Was that the right answer?
Yep. It's the Watergate complex,
cool.
Which is, bonus points there. That was, it's a crazy built series of buildings, if anyone's seen it.
Yeah.
Crazy
part of American history too. So
yeah, definitely. All right, let's look at some of the workflows now. So here's some 101, basically terrestrial laser scanning workflow. There's various methods, but basically what it comes down to is you're taking a scan and another scan and you're stitching them together, right? And then you repeat that process. Whenever you stitch two scans together, really you need three common points in scan 1 and scan 2 to get them to come together. And that's what this diagram illustrates. So you got the overlap between two scans, and then you got whatever the three common points are. They could be targets. You could have a sphere or a checkerboard target, or more commonly these days, less on targeted registration, more on cloud to cloud, where you just use elements within the scans themselves to stitch them together. But whichever way, this is kind of the crux of what's happening when you stitch scans together. So here's our blue scan. Here's our orange or red scan. But when the scans take place, the scanner just throws them on some arbitrary coordinate. They're not in alignment with each other. So you need to get those in alignment with each other and basically bring them together so they're relating to one another. Once you do that, then you start just repeating the process. In this case, we're looking at a plan view, looking down at a building, scanning around the outside of a building. And so that's the basic workflow. Now, when we stitch two scans together, there's always a degree of error. They're never perfectly aligned. And what's happening is, it's picking those 3 points. In the blue scan, it's trying to match it up with a point in the orange scan. And the distance between those points, they're not exactly in the same location as each other. So the distances between those points vary, and that's the error. And you can't eliminate it, so you try to control it as best you can and minimize it. But what happens is as you stitch these scans together, that error starts to accumulate and the scans will start to rotate and twist. And the more scans you stitch together, the more pronounced this becomes. And eventually, you can end up with some pretty significant error across a bigger project. So one way to control that is introduce survey control. And don't always need it, but in some projects you absolutely need it. So you bring in a total station laser and you create a point. It could be a mag nail on the ground. It could be a paper target on the wall, whatever that point is, shoot it with the total station, and you're just basically getting a series of coordinates that look like this, northern, eastern elevation. And it's a whole series of points, and you know precisely where they are. The nice thing about a total station is you can shoot a long distance with it, and so, generally speaking, you want to get your points out at the longest back sites, far apart from each other, and you get a good single measurement between those points that you have confidence in. So, so in this case, we got 3 scans. You can see they're starting to rotate out, and we set a control point, and we shoot where that control point is. And basically, what we're trying to do is bring those scans back into their proper alignment using the survey control. And this method works really well. It's a common workflow in scanning, but it's not always needed or required. Here's another way to look at it. Puzzle pieces. You stick puzzle pieces together, they kind of flex. That's kind of what's happening with scans, but really, that's how the puzzle needs to go together, and that's kind of what survey control does for you.
I think there's also a lot of development related to cloud workflows and how each piece of software handles it. And at the risk of sounding like we're complaining about kids these days, right? Like the computational horsepower that's available today for cloud-to-cloud processing is radically different than what it was even 10 years ago, right?
Absolutely.
So, but I think there's also some awesome stuff. Like, we're not the only resource, right? This video is going up on YouTube, but there's some other great videos on YouTube on each part of what John's talking about. So not to derail you, man, but there's so much good content here. So keep going. Sorry.
Yeah, no, that's and the cloud-to-cloud processes are getting better and better. The accuracies keep going up. But another reason you would maybe need survey controls if you want to geolocate your data, get it on real-world civil coordinates. So that's another reason to use it. But generally speaking, on a project like if you're in the last presentation that John Jr. put on, he was showing some massive projects, these stadiums, and you're going to want survey control on something like that. If you're doing your house, a small residence, maybe a small retail center or something, you may not need that. And you can
or if
avoid
you're
that.
ever going to come back to it, right? Like if you might return to the site in the future, you're going to want that survey control. That way your scans are aligned even when the physical conditions change, right?
Yes. Yeah, exactly. You want to reposition in the same spots, or get the new data set back in alignment with the previous data set. You want to avoid doing manual alignments if possible.
Yes.
Okay, let's look at other core technology, UAVs, drones. A lot of them doing either LiDAR. These got LiDAR units on them. You can also do photos and photogrammetry. A lot of different uses for UAVs. I like this one. For building documentation. You can fly your drone around a building, let's say, capture it from the outside. And in particular, I love this application, NERA. I don't know if you've seen it, John, but it's amazing for doing like investigations. So you get these super high quality photos, and it'll create a 3D mesh model of this building. And then you can simply, say you're interested in this element on the building, you can click on the mesh model, and up pops, the picture that pixel was on that you clicked, and you got a high-res photo there, but you got a whole carousel of photos that also share that same common pixel. So you can very easily see all the photos real quick versus digging through a network folder, to locate maybe a photo that you're looking for.
I've seen it online. I've never been on the creating end of it. So
It's amazing. It's a great application. And I don't get anything from Nira, but it's a,
it's
everyone,
it's a coping mechanism, though, right? We need all these tools because every single project that we work on is unique, right? And it
yep,
needs unique solutions. So,
absolutely. There's a lot of other applications for drones. That's just
mhm.
one of my favorite. Other thing, well, with drones, obviously you got regulations and things you got to be concerned with. You got to have your license. You got concerns about data privacy. Different property rights. You can only fly in certain places. What kind of battery life do you have? You don't want your drone falling out of the sky because of a battery or weather conditions, signal interference, that kind of thing.
Yeah, we do like work with sports and entertainment, and they have their own unique rules beyond just the FAA on what you're allowed to do. So there's that too.
360 imagery. Again, different flavors of 360 imagery. You see a lot of it these days. This is super fast and easy to capture. If you haven't done anything with 360, I encourage you to try it. It's not hard. It's relatively easy and expensive. These handheld cameras, they're great. They're used a lot in construction projects. I like using them for, I go on a job walk. I can take, like my Insta, and as I'm walking, I just flip on a video record. And as I'm walking with my client, we're just walking the space and we can have our conversation. I don't have to worry about sitting here trying to take notes and pictures and stuff. I can focus on the conversation, and then it's a great way to look back at things. But a lot of this is see pictures on plans. Yeah, go ahead, John.
I was just going to say, Stephen DeVito asked the same exact question. So we're hitting it all. So thank you.
Yeah. Picture on plans. This is it's a big use for these things. A lot of times you take these 360s, you pin them to a plan, kind of create your own little virtual tour. One of the problems, though, that we face is these pictures aren't easily transportable. If you want to switch to a different platform, it can be challenging. And this kind of brings up an initiative the US IBD is working on right now. It's US IBD E57 initiative, where we're working to develop it's like a plugin or something that goes along with the E57 standard. That E57 is a way to translate scan data easily between different platforms. And we're trying to get now photo imagery to do something similar. So if you're interested in that, reach out to me. I can get you hooked in with the committee who's involved in that.
Who owns the E57 file format?
It's an open standard. And it's, I don't know if there's an owner. There's a guy that that kind of controls the code. But it's an open standard that Gene Rowe of LiDAR News was one of the instrumental founders of getting the E57 started. And then it took a number of years in getting manufacturers on board with adopting the standard. So
I think
I would reach out to Gene. He can tell you all about it.
E57, if you're a power user, E57s are like your best friend, right? Like it's so often you're moving data around. So it's exciting to hear that we have an IFC equivalent on the reality capture side in E57. So
that's exactly what it is. It's like an IFC equivalent for scans and hopefully imagery soon. So, other types of 360 imagery. We touched on the Matterport. Again, this is probably some of the highest quality 360 imagery that you can get right now. Definitely a great solution. Not talked about as often, but I like these ortho imagery. Ortho imagery is great. You get this out of scan data, and one of the problems with photography, you take a picture of a building. Maybe you want to get this building facade, and you want to get it as orthogonal as you can, but with photography, it's like impossible. It's always got some kind of perspective to it. But with scan data, you can capture this facade and create an ortho image out of it. It's perfectly to scale. It's perfectly orthogonal, and this could be a great way to even save time. You don't necessarily have to create new line work. Depends on what you're doing. You don't have to necessarily create a model. You could just use export an ortho image and just draw on top of it for building repair, inspections, that kind of thing. Great way to streamline, developing, what needs to be done on this building.
John, that's such a good point you're bringing up, because I think the other thing too is that there's times that the point cloud data inside a modeling platform, the point cloud data seems to get like fuzzy, or it loses detail. So like your ortho imagery here, right? Like sometimes it's the only way you're actually going to be able to visualize your brick coursing or the actual precision elevation of a sill. There's certain details that just, it's like they just disintegrate in your hand when you're using a point cloud inside a modeling program that shall not be named. Otherwise, we'll just all start bashing it. All right.
Yeah. No, it's there's a lot of information in a point cloud that doesn't get represented. I mean, this is a form of measured data right here, visually measured data. A lot of times we're trying to convert measured data, point cloud, into something that's represented, a model or line work. But you don't always show everything that's in the measured data in that line work or model. So it's a great tool. You can do these in plan view. We've done them for ceiling plans. Great for historic preservation projects. We've used those on heritage projects. Also, floor flatness, another form of imagery you can get out of scans. And there's different ways you can represent it, either with like a heat map approach. You can do contour lines on the slab and see where your high and low points are. You need to level this slab out, where those spots are that you need to focus on. We usually overlay a grid of some sort, and then pick a base point elevation, and then contractor can snap lines out there, figure out how to find those high and low points. And then just, not to be overlooked by all this crazy tech, but just simple high-res photographs. One of the problems that we find with like the standard 360 workflow, you do a virtual tour of your space, but the image quality isn't that great. And if you zoom in, you want to see some detail, maybe some information, an equipment tag, or information on a panel that's going to fuzz out when you try to zoom in on it. So we augment a lot of times with just high-res stills, either from your phone, your iPhone, or Samsung. Don't get mad at me. I have an iPhone. Or just a DSLR camera. It's a great way to capture this kind of information and document your spaces as well. All right, let's talk about some workflows now. So kind of if I break it down into maybe 4 steps for a scan-to-BIM workflow, I would say this. There's kind of the reality capture component. Whatever it is, whatever instruments you're using to capture reality and process. In this case, I'm mostly focused on scans. So we can go out, maybe scan or do photo documentation. Second step being, you got to process that data somehow, typically, whether you're registering scans or, taking photos and, getting them into a platform where you can do the virtual tour and see stuff. then maybe you're taking it to the stage of modeling it. You've got measured data you've captured. You want to represent it somehow so it's more usable. You can work with it better. That would be maybe stage 3 here. And then just finally delivering to end users. So let's take a look at this again with point clouds. Once you've captured the data, there's the registration process, getting this scan stitched together. Using the software, you can make fine adjustments. Right now, some of the scanners, you're actually doing a pre-registration in the field where the scans are being pulled together into their alignment now, more automated in the field. It shortcuts the time back in the office to register your data and make it ready for the next stage. You're concerned with the accuracy at this point. Are you meeting your accuracy? Have you eliminated that error we looked at? Is it at acceptable ranges for you to move forward? A lot of times there's visual checks at this stage. You're checking to make sure there's no misalignments of the scans, doubling. A good example on some around, you find a round column or something and it looks like two crescent moons that aren't in alignment. So a lot of visual checks as well.
Yep. Yeah, finding those double wall conditions, right, where the wall surface isn't actually on the same plane, and you have one wall here, another wall there, and it's like, oh, now I gotta fix it.
Those are the same wall. They shouldn't be doing this. It should be that. So that's a registration area. You want to fix those things before you move to the next stage. So also you can noise reduction. There's different errant points often in the scans, or you come across a situation like this where there's a mirror and it's going to cast points out here. It's going to reflect points, things that don't exist. So you want to maybe clean those things out. And then there's also filtering. You can filter out data. Okay, we don't want this truck. You can filter that out. And some of the scanners have a double pass feature. It'll take a scan and then it'll take a second scan, and it looks and it compares to see did the points match up or do they look different, and they can detect a moving object. So any points that don't match up between the two scans, it scrubs those automatically and helps clean the scans.
Yeah, moving object filters are incredibly helpful if you don't have exclusive access to the space. Just construction sites with trade contractors, craft workers going this way and that way, your ability to just kind of remove everything except the thing that you care about. So helpful. So helpful.
Yep. You can also do point cloud segmentation. There's software that will help you segment your point clouds. Maybe you want to isolate, hey, I'm going to put furniture, casework, whatever, on a different, I want to segment those points from the walls or from doors. So there's tools that you can use to try and segment your point clouds. Sometimes we've done this with MEP, where maybe you want to isolate the different systems from each other. You can do that as well. We talked a little bit about E57 as kind of that IFC type, what IFC is for modeling, E57 is for scan data. That's one way you can publish scan data, but there's a lot of different formats. You need to think about this if you're working with scan data, because it can take hours to publish and export data from one format to another. If you want to bring it into a modeling platform, you may need it in one format or another, depending on what the software works with. Don't forget to account for the time for the exports.
Or the budget, right? Like I think sometimes scan projects, if you're picking up a big one and it's bigger than what you've done before,
yep.
Tell your boss.
Yeah. If you're using different instruments, they may put data out in their proprietary formats and trying to get them into a common format that you can work with those together. You can burn a lot of time if you don't plan that out carefully. You talked about data size in your last session, but large file sizes, this is a big deal. Make sure that you're thinking about this. You've got adequate storage, you've got adequate processing power. You're dealing with, not just gigabytes, but can be dealing with managing terabytes of data.
Yeah.
Your IT guy is going to come talk to you at some point, most likely, when he sees you consuming all that space.
So talk to them first. Tell them what you're going to do, right? Like just set those expectations and then make sure, at least for me, I feel like life's hard enough when we're scanning. Like over provision, have faster computers than what you need, have way more storage than what you need, because you're going to have problems. Don't let it be the computer. Don't let it be your storage. Have a good problem instead.
Yeah, another thing, this happens. We've had this happen to us. Most of the time almost all the time you're working on your local machine with these point clouds. And when you're processing data, a lot of times you need a cache space that's quite large. So if you don't have adequate, you may think, okay, I got plenty of space for this data set. But if you got to process it and it needs a cache that's almost as big, you could run out of disk space locally just to process it. And usually when that happens, it's not at an opportune time. So it becomes a crisis.
Yeah. It happens at 2 a.m. in the morning, 72 hours before something needs to get delivered.
Yes. So think about that. Make sure your local hard drives are large enough for the processing side. This is interesting. There's a lot of opportunity, should I say, to improve efficiencies in this space. And as practitioners using the tech, we're really desperately in need of better hardware software solutions to automate a lot of this. I think a lot of stuff has been improving on the capture side. The representation side still has a long way to go, I think. It's a very manual process to do a lot of the modeling, although there are programs that are helping with that, but there's still a lot that can be done, especially if you get into unique conditions, where maybe you got a lot of detail. You really got to spend a lot of time doing a lot of hand modeling. And you definitely need to verify any automations that you're running. It doesn't always get it right. So don't always just go with what it kicks out. Here's a couple of programs that are helping to automate Edgewise or Point Fuse. They can automate or semi-automate wall elements or MEP elements. It'll auto recognize these cylinders and it'll create a pipe for you. And there's usually a cleanup process that goes with that. So these tools are out there, but there's still a lot of automation that this industry can benefit from. Here we got our AI guy confused as well. He's like, I need some help. But AI, we're hoping, I think AI is going to help us accelerate some of the automation. Still not sure exactly how it's all going to work, but there's a tremendous amount of hope now that this is going to help streamline some of these inefficiencies and help automate things. But we'll see. I think over the next 2 years, we're going to see a lot of advancement.
Yeah. We had a question from Radu about how do you load these files into Revit and not have it explode into a million glittery pieces of magic? I'm rubbing my eyes just thinking about it because I've been there myself. But what do
Yeah,
you think?
great question. Well, one probably the easiest thing to do is decimate your data. You don't necessarily need all the points that you've captured. Be careful what resolution you're scanning at the capture stage. A lot of times people are over capturing. They don't need the resolutions that they're scanning at. If you go into a small room, dial back your resolution on your scan. You don't need that many points typically. Or if you've got, say it's an open office situation, you're going to drop a number of scans in this open office. You got so much overlapping data. Again, you can drastically reduce the resolution on those scans and still come away with a lot of more than enough points for what you need. And then when you register it, decimate it. We usually have a full res, that was a full capture, and then a decimated version. And most of the time, our modeling team is importing a decimated version, and it's more than sufficient. It's a lot more fluid when they're modeling. You're not having that lag and on screen refreshes. You're saving time. And then if you do need more detail on something that's not quite showing up, load that full res data set. That would be my recommendation.
Great strategy. And then the other one is also to chunk it, right? Like divide it into areas so that
Yep.
if you're only concerned about this one space on this one floor, you're not carrying, the 2 floors above it and the 2 floors below it.
Yes. Yeah. Creating smaller data sets and then just, loading the one that you need to work with is a great strategy as well.
Cool. Thanks.
Yeah. Great question. Other thing, I'm going to shift to what we call, I always like to refer to design BIM versus existing conditions BIM. And this is a big deal because design BIM is great. You design something in BIM, there is no accuracy tolerance. You talk to most designers, they don't know what LOA is, level of accuracy. What's LOA? USIVD has an LOA spec. How do you specify accuracy? In the design world, you want 40-foot column spacing. You make it 40 feet. It's perfect. There's no error in that, right? It's design. And everything's orthogonal, and BIM tools like orthogonal modeling. And but in the existing conditions world, where you go out and you scan something, it captures every out of plumb condition, and you bring that into a BIM authoring tool, and you need to model it. Now you've got, my wall is orthogonal. It's perfectly flat and vertical, and it wants to model it, 90 degrees to the next wall, but the point cloud shows it's off by a slight degree. How do you deal with that? How do you make sure you're meeting your accuracy spec? Am I going to be within a 1/4 inch or better on a project? So this is a big challenge for those of you who are dealing with existing conditions. So some of the big differences here. The design BIM that's idealized. That's design intent typically. There's no real world deviations illustrated there. Existing conditions there are. You have to decide what deviations you're going to represent, how accurately you're going to represent those in your model. And then LOA becomes incredibly important, as to being a guide as to, like, for example, a pipe. We come across, we do above ceiling scans, and you got a pipe that's sagging, right? So the scan captures that sag, but in the model, do you need to represent that sag? When you design it, you're going to draw it nice and straight. Modeling tool is going to want to draw it straight, but if you have to maintain that sag to meet your accuracy requirement, that could be a problem. We talk about LOD and LOA a lot, level of deep development, level of accuracy in design or in existing conditions BIM.
I think it's so important too with all of these items, John, right? That you talk about it up front. Because I got a favorite saying, and it's expectations are resentments you plan in advance.
Yeah.
Right? And
Yep.
so if someone's expecting that pipe sag to be there or things like that to be there in the existing conditions model, or expecting it to be the opposite, if you don't talk about it, you don't air out those expectations, it can lead to resentments after the fact.
100%. Yeah, setting those clear expectations up front is critical. And there's so many things to set an expectation on. But tools like these industry standards, the BIM forums, LOD spec, the USIBD's LOA spec, are great tools to help you define these things and set these expectations up front.
Define the expectations. Exactly.
Yeah. So, and both of these are free downloads. So go get your copy off the BIM forum and USIBD's website. Definitely need those if you're doing existing conditions. The future, AI, automation, digital twins. This is these are the big catchphrases these days, right? BIM is a thing now. Laser scanning's a thing. Those used to be the future. Now they're like commonplace. Okay, AI, automation, digital twin, right? But these are the next frontier right now, and we don't know exactly how it's all going to play out, but it's going to play out, and things are going to get better for all of us that deal with this stuff. Repetitive tasks are a great target for this. Automating the workflows for modeling is going to be key. Things like, we talked about MEP, is there an even better way to help automate this stuff? I'm really hoping for AI is going to help us. Really, the ultimate thing that the industry is still trying to get to is digital twin. And all a digital twin is you get a lot of different definitions for digital twin. But one thing basically you boil it down to is you create a digital representation of a physical real world, structure, right? And being able to take and marry these two things together so that you can better manage your building is a big part of what digital twin is.
Is that you?
It's
I'm hearing a xylophone in the background.
It is. There's some. I thought I killed it. It'll stop in a second. Sorry about that.
Is that our chime to remind us to ask the audience for questions?
I think we're getting pretty close to that. Yeah. It's like, okay, wrap that up. No, basically we're trying to connect the digital world to the physical world with digital twins and be able to monitor performance on our buildings, what's happening with the HVAC system in real time. For a transportation facility, maybe you're concerned about people counters and how many people are flowing through the space in real time. But it's not easy, and it's kind of the next big thing. But yeah, no, there's shifting from manual to AI-driven automation is where it's heading. AI will make it easier to capture this stuff and represent it. And then still needing a lot of oversight. If any of you have been messing around with AI, doesn't always get things right. So that QC process is still going to be really critical.
Yep.
So
I don't think the marketing hype in AEC has ever lived up to the technological deliverables, right? Like everything needs to be taken with a grain of salt.
Yeah. All right, there the bell went off, so the Q&A starts. What do we got? Let's see. Monty has let's see, segmentation, automated segmentation of point clouds.
Let's see if we can throw this up there.
Yeah, what do we got there? AI solutions, mostly because the definition of granularity of objects vary. On the bright side, because of LOA requirements, as well as LOD guidelines. Let's see. Oh, yeah.
I think it's from Manny, this is more of a general statement, right? There's a few AI solutions that are emerging in this space, but
Yeah.
yeah.
One of the things he brings up uniformat. One of the things with the standards, we've been, at least with LOA, I'm pretty sure with LOD, we're trying to also unify the standards, help them work better together, have that interoperability between standards. And the LOA is built on the CSI's uniformat. It also, we looked very closely at how the BIM Forum created their LOD spec and the progression from LOD 100 to 500. We tried to mirror that with LOA 10 to 50, and try to keep these things relatable. Let's see, what other questions do we have? Can you give more info on orthogonal photogrammetry? So yeah, this is from Edmund. Basically, yeah, I don't know what your particular question is, but orthogonal photogrammetry, or is
So
really
I mean, when you're creating an ortho from your software, it's usually, tell me, John, at least for me, it's like I'll cut a section through the point cloud data and say generate an ortho photo from
Yeah.
the point cloud data.
Yeah, you can do it with like
Mhm.
a section through the point cloud and do an orthogonal section. These are great as well. It's just another way to publish point cloud data, but we've used these to reduce or eliminate the need to do modeling.
Yep. Yeah, I think that orthogonal photogrammetry is maybe a little bit different than ortho photos created from LiDAR data,
Yeah,
because photogrammetry has inherently a bit more error to it. So trying to produce detailed documentation is challenging. But yeah, I think that's maybe just a terminology thing. Whoa, all right. We're getting a lot flying into the chat here. How about this one from Sankar about the interaction between reality capture and 4D scheduling to track progress?
I'm going to let you grab that one, John, because we don't do a lot of 4D with what I do.
Yeah, so we're actually working with two different companies right now and using 360 photos and, more importantly, 360 video walkthroughs. It's really exciting where kind of 4K and 8K 360 video walks are taking us, because there's tools now that can turn that into photogrammetry just from a video walk, because the image density from a single frame on a 30 frame per second video is enough for photogrammetry. But there's tools out there now that we're trialing that let us take the model and then do a video walk, and it will use machine learning to track our installation progress back to the model. So that's incredibly powerful on a number of different levels, just from understanding how complete the work is, understanding our week to week progress. So I mean, it's potentially a game changer for pay applications, right? Like if we can pay our trades based on the actual linear footage of pipe and conduit they're installing, all of a sudden we've incentivized performance. All right, we got a bunch more here.
Yep. What's a good one there? What is?
Yeah, this is. I mean, Naveen has one that this is this is. I don't know, Nirvana. This is would be amazing, right? If I think Edgewise and is it Point Fuse? Was that the other one you were
Yeah,
mentioning?
yeah. Point Fuse is another one. I don't know how deep in they've gotten with AI. Um, so again, this is still all very new. I mean, when did you start learning about AI? I mean, for me, it hasn't been that long ago. And I'm like, what's Chat GPT, right? And then you
Yeah,
start, holy moly, this is crazy.
right.
Um, Getting that into modeling is a lot more tricky. But I think we can see that there's definitely going to be applications coming out to streamline this stuff.
It's gonna. I mean, I'm excited. I'm excited to see it, but we're all gonna have to take it with a small helping of salt because the AI hype is at times it's overwhelming. Just makes you want to shut it all off.
Yeah, there's one in here. Is it Randy? I think talking about VR and AR.
Yep.
Are you guys using any of that on your construction projects, John?
We have um we have um a Trimble solution that's built around the HoloLens. And it integrates it into a hard hat. It's got a slick bone conducting microphone and speaker system. But I I feel like AR is more applicable from a construction use than VR, just from a safety perspective. Um, but I think our big challenge with those tools so far has just been graphical performance and the ability to locate yourself correctly in the space to where you have a level of precision, right? Like point cloud data, it's if you're doing it correctly, incredibly accurate. And AR is kind of, I don't know, horseshoes and hand grenades. You get it within a couple inches if it can, um, but it creates some challenges. But
Yeah, that's one of those technologies that you see it appear a lot, but I don't know how well it is ready for prime time still. I think there's
yep,
a great opportunity if they could, dial in the accuracy on where it's located. And I'm not sure what the practical use cases are yet. I'm still kind of
yep.
wondering if you guys are using it much.
I mean, limited. You're asking like AR and VR. Are we using it? We are, um, but I would tell you that I think what has generated more value is just getting the model and point cloud data onto iPads. Um, so not to talk to a specific brand, but like the performance factor of the M4 chips is spectacular. So the ability to put that into everyone's hand on our construction sites that has an iPad, which is pretty much everybody from entry level field engineers all the way up to senior general superintendents, does a lot to democratize the ability to share the digital data.
Yeah, one thing I think of with like AI, there's like a kind of a learning component behind that, right? The more you start to interact with it, the more it's learning. And I'm curious how this is all going to play out where, you're training your AI, right? Whatever AI you're using. Um, is there going to be a need for like an E57 for AI? Maybe you're working with this one AI, system and you want to switch to another AI system. Can you take all that machine learning with you? I haven't seen much on that yet, but I would think that's going to become a thing as well.
Uh oh. You've got all the clocks, all the timers for us. I think we've got like what, 120 seconds left here.
Yep.
Um,
The cuckoo
but
is cuckooed.
yeah, we've still got some more great questions. So maybe if we we'll post process some of these questions and see, maybe there's another webinar we need to do. It seems like there's some more questions around Edgewise and other tools that allow you to model. So maybe there's a webinar we need to do on best practices for reality capture for different modeling uses. But if folks have any other future follow-up items they'd love to see us hit on, feel free to throw it in the chat in the last few minutes here. But
there's also something just to build some awareness. BIM Forum and USIBD are currently working together. We're just starting an initiative right now to kind of tackle that elusive LOD 500 realm, where, you know, say the design BIM world and the reality capture BIM world, the existing conditions BIM world are colliding kind of at that stage of, you know, as built existing conditions BIM, right? And the need for standards to be developed around that. We're just forming a working group right now. If you guys are interested in participating in that, we'd love to hear from you.
Yep. And Jim, yes, the recording will be available. We're going to post it on YouTube, and through your registration link, you should be able to get back to the recording just pretty much as soon as we hit end on the live stream here. But I think with that being said, thank you for everyone who's attended and listened. I feel like we've had a vibrant and lively chat. So until the next one, which I think is going to be the third Wednesday of the month. So there'll be an email blast going out on that, or find us on LinkedIn and you'll find out about our next webinar. So thanks, everyone.
Thank you, everybody.
Cheers. Bye.